Hey guys, welcome back to my channel. In today's video, we are going to see how to solve this problem called reverse level order traversal. Right, so it's basically to print the level order traversal but in reverse order, right? So let's see what do I mean by that. Let's say this is a tree, right? So 1, 3, 2. So a level order traversal will be 1 and then 3, 2, right? But here we are not printing in that order. We are printing in reverse order. So first the lower level, that is 3, 2 will be printed and then 1 will be printed, right? So similarly 10, 20, 30. So this is a tree. So we are printing reverse, right? So it should be 10, 20, 30, then 40, 60, right? But we are not printing in that manner. So first start with the lowest level. So it will be 40, 60 and then 20, 30 and then 10, right? So the question is pretty simple. So let's understand this once again. So let's say this is a tree and the output should be like this. So basically we are starting from the last index, right? Sorry, the last level, right? So here level 3, we are starting from level 3 and then printing all the nodes, that is 7 and right. Mind it, we are printing towards right hand side, right? So 7, 8 will be coming at first and after that this level. So 4, 5, 6 will be printed after that. So 4, 5, 6. Then after that go to the above level, that is 1. So 2 and 3 will be printed. So 2 and 3 is printed. Then after that you are going to the first level, that is 1, right? So 1 will be printed. So you are just printing the nodes in level order traversal, right? But the difference is you are actually printing from down, right? You are printing from the lowest level and you are coming to the upper level, right? So to implement this, there are two ways, right? There are two approaches. Although it doesn't matter because the time complexity and the size complexity will be same for both of them, right? So let's look at each of them, right? So the first approach tells something like, bro, we just have to print the level order traversal, right? And also we have to print in reverse order, right? One thing we have to keep in mind that we have to print in the direction from left to right, right? So can I store the elements of all the levels separately in some vector and then store all these vector in a vector? Basically a vector of vector I'm going to create, and then inside that vector I will be having these all vectors, right? So inside this vector I will be having 1, then 2, 3, then 4, 5, 6, then 7, 8, right? So what I'm going to do, I'm going to iterate from the last vector till the first vector, right? And I'm going to print all the individual elements in that vector from left to right. So let's look at the code. It's basically the standard approach for doing level order traversal, right? So basically I'm using Q because I have to print level order traversal, right? So I'm just using Q for that. And then here I will be storing these levels, like individual levels, right? Individual levels, all the elements in a particular level. So I will insert the root and then I will check for this condition, and then what I'm going to do, I will just pick up the size, right? Let's say I have some size, let's say I have 4 elements. I will just pick up the size and I will just take out all these 4 elements, and I'm going to push that element into a vector that is declared here, right? So in each level I will be declaring separate vector, and then at the end I'm going to push this vector into levels, right? So vector will be having all the elements in that particular level, right? And then I'm going to push this in a vector called levels, right? Levels will be having multiple vector of different levels, right? So once I got all the levels, I'm going to traverse from the last vector to the first vector, right? So let's say there are so many vectors and the indices are 0, 1, 2, 3. It basically shows the levels, right? 0th level, first level, second level, third level. So I'm starting from the last, right? Level dot size -1, which is basically the index of the last vector, right? So I'm going to print this and then I'm going to decrease this index. I will come here, then I will print this. I will come here, then I will print this. I will come here, then I will print this, right? So that's what I'm going to do. So in this, I'm just printing all the elements in that particular vector, right? And then at the end, I'm just returning the answer, which is a vector. right? So the time complexity is of n and space complexity is of n. Although we are taking vector of vector, but total space will be of n. So space complexity will be of n. So now let's have a look at the other approach, that is approach 2. So in this approach, what I'm trying to do is basically see, this is the answer I needed, right? So this is the answer I needed. So can you observe something from here? Can I print this? Like directly, can I print this? I think I have to think a bit. So can I go for like printing this value? Okay, I can print this. I can print root. Can I print this 3? Okay, I will go to right and then print this. Okay, fine. Can I print this? Okay, so after going to right, I will go to left and print this. Okay, fine. Can I print this? Okay, so right, let's say right is pushed in the queue, and then I'm going to print the children of this, right? So right side there is no element, so I'm going to print 6. So 6 is there, and then I'm going to the other element, that is 2, and I'm going to the right side, so 5 will be printed and then 4 will be printed, right? So can you observe something here? Can you observe something here? So see, normally what we are doing, we are actually doing this level order traversal in left to right format, right? So let's say I am at this node, so I will just print this and then I will go to left and then I will go to right, right? So we are not doing this. So right now what I'm saying, print this node and then go to the right hand side and then go to the left hand side, right? So first go to the right hand side. So in that way we can actually print something like this: 1 3 2 6 5 4 8 7, right? So since you got this, you just have to simply reverse it, right? So reverse this to get this answer, right? So the code is very simple. It's actually very short than the other one. So the most important part here is just to understand like why I am doing this, right? So I'm going to directly declare a vector that is answer, and then I'm going to do a level order traversal. But here I'm going to the right hand side at first, see, right hand side at first, and then I'm going to the left hand side, right? So I'm just printing the node, then going to the right hand side, after that going to the left hand side, right? So once we get all the elements in level order, just reverse it, and then return it. So here also the time complexity is of n and space complexity is of n, because we are actually storing all the elements in answer and then later on we are actually reversing it. So if you want to ignore this, because see, answer vector is anyway the vector that we have to return, right? So if we want to ignore this, I can say space complexity is of 1. So we are not taking any extra space, right? So in a way this is more optimal than this. It totally depends on how you see it, right? So if you are looking for extra space, then we are not using any extra space, right? So I can say in a way this is the most optimal answer. And before ending the video, I just have to tell you something, that this is a new channel and I'm just uploading it regularly, so I want you guys support. So if you like this video, it will be very helpful for me. And if you haven't subscribed, please subscribe to my channel. Until next time, see ya.